Hello? Okay, good evening, everybody, and you're welcome to Mama with Jarvis, but it is the Midnight Sun project. And like I said, the Midnight Sun project is a project that takes into consideration preparation for WAEC and stretching the boundaries of grade 9 to 10 to 11 to 12. And today, we're going to be treating a very, very interesting topic. And this topic is called circle geometry, or rather circle theorem. Now, it comes under a branch of maths we call geometry, and it will focus on, now there are two aspects to circle theorems, or sometimes some folks will call it circle geometry. There are two aspects to it. There is a part that tends to arc, chords, circles, and what's the last one again? Cyclic chords. There is a part that tends to alternate segments and tangents. My focus today will be trying to look at the introductory aspect of which is arc, chord, and cyclic chords or quadrilaterals. The short form of quadrilateral is what? Chord. So I really need you to sit back, and as is the practice in this course, I'll try to solve questions and draw your attention to certain theorems that you must know to handle the problems. A quick reminder here that the focus is not on your ability to memorize the theorems. No, the focus is in your ability to identify the theorem and know what to do. So let's hit the road. So my first question of interest will come from 2021 WAEC. 2021 WAEC OBJ. So I'll just say WAEC 2021, that'll be June. It's OBJ. And then we have a few questions here. So we'll just start with question number, what was that again? Question number 30. So I'll try to draw the diagram. And the interesting about this topic is that we may not cover too many questions, except time permits us to do that. But we'll try to be as slow as possible. So as I draw, one of the reasons why I draw as I teach is that so you see the diagram and understand how it goes. You can also go back to the question paper here and then try to solve it. All right. So we have a circle, and it looks more like this, something of this nature. This is P, this is Q, this is R, and we have a center here. More often than not, when you see this in geometry, this word center, that center is connected to this point, and this one is connected to this point. And then we're told that this line is parallel to this one. So I'm going to draw another. And this is S. And I'm told that this angle here is what? 72 degrees. So this is the diagram we are given. We are told that in the diagram, O is the center of the circle. O is the center of the circle PQRS. The points used to draw the circle. And that angle PQR is what? 72 degrees. And that OR is parallel to what? PS. All right. So we're going to find angle OPS. OPS. This is angle they want us to find. Find angle OPS. So as is the practice, I will label this. I know I need to look for this angle. So I'll call that angle X. And I could call this angle Y, because I'll need to get this angle to be able to get this one. Is that clear? And then I think we'll be having a few questions that will go in this direction too. Now, I will tell my examiner if this were to be theory. Remember that although it's OBJ, I always solve with the template or with the imagination that it could come out in your theory and you have a responsibility to solve it. All right, so I would say using notations as in diagram, comma, we're going to have that what? Look at this, y will be equal to 2 times 72. What's the reason for that? Now, there's a theorem you need to remember that the angle at the center is equal to 2 times the angle at the circumference. So if I have a figure like this, the angle at this center must be equal to 2 times the angle at the circumference. So with that, I will say angle at center. I put a dot meaning center equal to what? 2 times angle at what? Circum. You could write it in full, but for me, I always like to use the shorthand method. So you can write angle at center equal to angle at circumference, but I just had to use shorthand here. So which means y will be equal to 144 degrees. Now let's look at this diagram very well again. Now, because this is parallel to this, it means that if I add x to y, I will have what is called the what do you call this thing now? Co-interior angles, or what is called the allied angles. Co-interior angles, or what is called what? Allied angles. And if these two lines are parallel, it will mean x plus y will give me 180. So we say that co-interior angles or allied angles are what? Supplementary. You may want to look up some of my videos on this. I've done an extensive video on this called point, lines, and angles. Go look up that video and you get this understanding better. So that means that x plus y will be equal to what? 180 degrees. So what's the reason? Allied angles. Allied angles, what? OR rather parallel to what? OR parallel to what? PS. Okay, so with that settled, I already know y. So x will now be equal to x plus 144 will be equal to 180. And x will be equal to what? 180 minus 144. And if that is done correctly, x becomes what? 36 degrees. And that solves the problem. But remember that we were told that angle what? Angle, we're told to find angle OPS. So I will say angle OPS is equal to x. It was I who said that it is equal to x. The examiner didn't tell me that it was equal to x. Remember my initial description, I said using notation as in what? Diagram. And as such, this is the answer we're going to get. I'll give a minute or two to pause and to feel what we've done. Okay, so if we're through with that, we may want to go into the second problem now. Okay, let's try to go into the second problem. We'll try to go into the second problem. All right, so I'm done with that. Let's see, is there another one? Okay, there is another one on that same year. I'm going to try to draw it on the board. There's another question in that same year. That is question, the first one I solved was question number 30. And the next one is question number 36. Oh, I got that right. Question number 37, rather. Now, this is the diagram we have. Look at it. The beautiful thing about this topic is that by the time we start solving problems, you get used to it. And this is what is called a cyclic quad. A cyclic quad is a quadrilateral drawn inside the circle. A cyclic chord is a quadrilateral drawn inside a circle such that the points of the quadrilateral touch on the circumference of the circle. A cyclic chord is a quadrilateral drawn inside the circle, and some people use the word inscribed on the circle to put inside, and such that the points of this quadrilateral touch the circumference of the circle. So we're going to have here P, we're going to have here Q, rather S, sorry about that, P, Q, because the teacher decided to name anti-clockwise, R, and S. We always take a definite pattern when we label, all right? So with that settled, and we're giving the sides X, we're giving this side to be what? 2y minus 30 degrees. We're giving this side to be X, and we're giving this side to be what? X plus y. All right, so if that is done correctly, there is a very important, that in the diagram, PQRS is a cyclic, is a circle rather. Find the value of X. Now, there is a theorem we need to remember here. Like I said, it's not about memorizing theorems. No, it's about knowing that that theorem exists and knowing how we use it. Now, the theorem says that if I add the opposite angles of a cyclic chord, sum up to 180 degrees. The opposite angles of cyclic chords sum up to what? 180 degrees. What that means is that if I add this to this, it will give me 180. And if I add this to this, it will give me what? 180. So I'm going to say that X plus X plus Y is equal to 180 degrees. What's the reason? Cyclic chord. So I'm going to simplify this, and this will give me 2x plus y equal to 180 degrees. Then I can add these two together to be going to be what? Supplementary. So that means 2x, 2y minus 30 plus x will be equal to what? 180 degrees also. What's the reason? Cyclic chord also. Cyclic chord, that's just the reason for that. All right, so the next thing we want to do is to say, and look at this. This will be x plus 2y equal to 180. And I'm going to take this to the other side. This is slave becoming a servant. And as such, that will be equal to that. So x plus 2y will be equal to 210. So we can actually now solve this simultaneously. We can solve this what? Simultaneously. So I can pick the... Now, we are told to look for x. And because I'm told to look for x, I must eliminate y. So I'm going to write that out. That will be 2x plus y equal to 180. I'm going to have x plus 2y equal to what? 210. So in eliminating, what I don't need is y. So I'm going to eliminate y. So I'll multiply here by 2. And I'm going to get new sets of equation. Now, you see that it was a simple, what's that called now? It was a simple idea in cyclic chord, but it's taking you to simultaneous equation. And that's why I tell students there is a network of ideas or connection that exists when you solve problems. Don't say I know one topic and I leave the others. No, you have a responsibility to try to handle and know all the topics. All right. So this will be what? 2x, 4x plus 2y equal to 260, and that will be what? X plus 2y equal to 210. So we can do our subtraction, and that will be 3x minus 3x. This will be 0, and this will be. You can also look up my video on simultaneous equation. I've treated elimination method extensively in, I think that's during my grade 9 class. So you go to my grade 9 playlist and you find that video there. Algebra, simultaneous equation by elimination method. Right. That will give me what? 150. And if that is done correctly, it will mean that what? X will be equal to 150 divided by 3, and x will be equal to what? 50 degrees. So in that question, x becomes what? 50 degrees. Okay, so I'll give us a minute or two to cool our head, and then we'll go to the next. All right, okay, just trying to ensure that to see if we have people online watching, and then at least be cautious enough to respond to any of the issues that may be coming up. So I'm going to clean up the board. And please, the reason why I'm very slow here is that I want to ensure that you understand what is happening. You understand what is happening. All right. So that taken care of. We have one more question here. That's question number 40. Question number 40. And how does that question look like? So let's try that one out. It says, we're going to draw the diagram. We're going to be drawing a lot. That's the thing with this one. You really don't need to be an artist to do well here. All right. Okay, so that's drawn. Next thing I'm going to try to do is to pick this to this point. I hope I done that well. Then I'm going to pick this to this point. I'm going to connect to this point. And I think I have my diagram intact. And then this is A, B. We always follow a definite pattern when we label A, B, C, and D, E. So the label is either done clockwise or counterclockwise, right? So if that is done correctly. Now, this is where you must pay very close attention to this question. Now, my diagram may not be very perfect, but the question says that, okay, let's adjust this a little more. Because I'm told that, adjust this a little more so that it looks almost real. All right. So look at that. The whole of this angle here, this is C. The whole of this angle here is 158 degrees. So we're told that in the diagram, EC is a diameter. EC is a diameter. And if EC is a diameter, this angle formed at this point must be 90 degrees. Did I get that right? Oh, sorry about that. Sorry, I missed the idea. Now, if this is a diameter, the angle formed at, okay, we'll come to that later. The angle formed at this point must be what? 90 degrees. We call it semicircle. Call it what? Semicircle. So the angle formed at this point must be 90 degrees, all right? Now, we are told to find the angle ADE. So to find the angle ADE. Now, this is the angle they want us to find. So to get this angle, I must get this angle. So to make my work easy, I'm going to call this angle X. I'm going to call this angle Y. And then, please, let's remember, I said that for a semicircle, this is a diameter. Anytime a diameter exists, and I draw a triangle on that, this angle here, let's get another marker. My board is not cooperating. This marker, all right, this angle becomes what? 90 degrees. So it follows that 90 plus X. Okay, I have to tell my examiner first, using notations. As in diagram, what happens? X plus, okay, let's say, okay, let me call this one A, small letter A. So angle A is equal to 90 degrees. And what's the reason for that? Semicircle. Semicircle. This diameter, this diagonal is going to cause, this diameter is going to cut 90 degrees with this triangle. So A is equal to what? 90 degrees. So if that is settled, I can say that A plus X is equal to 158. It's given. It's given. I don't need to calculate that. All right. So with that, 90 plus X will be equal to 158, and X will be equal to 158 minus 90. And if you do your maths very well, you're going to get 68 degrees. So it means that this angle X will be what? 68 degrees. Now, look at this angle here and look at Y. X or Y is equal to X. What's the reason for that? X will be equal to Y or Y will be equal to X because of what? Same segment. So what segment is that? Segment what? AE. Same segment AE. I want to do extensive videos. I've done videos on this. You may want to look at my grade 11 videos on circle geometry, cyclic chord, I think. So if you look up that video, some of these ideas will come better. But I'm doing a reboot on this work, and I think by the time I do that, when you rewatch this video, it becomes relevant to you. But those who have been taught this topic will understand what I'm doing. Now, look at it. I was about saying something that same segment. This is a segment, AE. When we say a segment, all of this is a segment. A cutout from a circle using a diameter, usually a chord. Whenever a chord cuts a circle, what you obtain will be two segments, either a minor segment or what? A major segment. So this area becomes a major segment and this becomes a minor segment. So we say that segment what? AE. Right? Now, what is X? X is essentially what? 68 degrees. And as such, we have that what? Y will be equal to what? 16 degrees. Let's see whether we have an answer like that. Yes, we do. So, but remember that we're not told Y. You need to tell your examiner that angle ADE, angle ADE is equal to Y and is equal to what? 16 degrees. Always give your examiner that respect of trying to finish your work very, very well. Right? So that's taken care of. And I think we're done with one question paper for that year. All right. So we go to another year. Give us some time to cool off on that. Then we go to another year. Okay, I don't think that will take so much space. So maybe I'll just do that here. WAEC. Is this WAEC or NECO? Let's confirm. It's actually NECO. Sorry about that. It's NECO 2020 OBJ. OBJs, NECO 2020 OBJ. Now the question says we're going to draw this. We're going to draw the diagram. Okay, more like this, with center. With this. Well, I told this angle is 206 degrees. This is coming in this direction. This is P, if I got that right, or R rather. That's R, that is Q, and that is P. Right? We are told that if O is the center of the circle, in the figure below, find the value of angle PQR, angle P, sorry, PRQ. We're told to find angle PRQ, so we're told to find angle PRQ. So I'll call that point X. Now I'll call this angle I need to get here Y. because this angle is connected to this angle. Now, how do I get y? Remember that from your types of, relationship between angles, there are 3 types of relationship you can have. We have the relationship that talks about what? What do you call that now? Complementary angles. We have that talks about what? Supplementary angles. And we have that talks about what? What's the last one now? That talks about what? Angles at a point. So we're going to use the angles at a point concept to handle that. So y, okay, using notation as a diagram, always remember to write that using notations as in diagram, and y plus 206 will be equal to 360 degrees. What's the reason for that? Y plus 206 is equal to what? 360 degrees. The reason is what? Angles at a point. So the angles at a point will give us an understanding of how to handle that. So what that means is that y will be equal to 360 minus 206. So what does that give us? That will give us 154 degrees. And that will mean that this will be what? 154 degrees, and we are done with solving that question. Hi. My light has become a big challenge. Oh, I didn't even pause. All right, let's hope that this my emergency arrangements do not collapse. All right, let's see. Okay, so we're done with this. We'll go to the next question. There's another there. Sorry about that. All right, we also have question 41 there. And in question 41, we have another diagram. Okay, we have this. We have this center. This is a cyclic chord. We've explained what a cyclic chord is. A quadrilateral inscribed in a circle. So this is what? P, arrow. The writer has named anticlockwise. Q, S. We are told that this is what? 107. And we are told to find angle ROPS. This is what we are told to find, ROPS. So remember that I'll just call this X. It's even very convenient to call, okay, there's something I forgot to do. Did I finish this question? No, I did not. So sorry about that. I didn't finish this question. Now, y is equal to 154. So what does that mean? We know that y is equal to 2x. The angle at the center is equal to 2 times the angle at the circumference. So angle at center equal to 2 times angle at circum. The word circum there will mean circumference. So if I know y to be 154, so I can say 2x is equal to 154 degrees. If I got that right, okay, should be correct, which is x will be equal to 77 degrees. I am not told to find x, I'm told to find angle PRQ. So I'll say angle PRQ. So sorry about that. I think the interference I was having from my light source took my attention off concluding that problem. So that angle is 77 degrees, if I got that right. Okay, that settled that. Now, look at this. We said that what? Using notations as in diagram. This is a technique I use, and it's been working for me for years now. Now, I told to find angle ROPS. ROPS is this angle here. So look at this, x plus 107 is equal to 180 degrees. Now, I told us earlier that the opposite angles of cyclic quadrilaterals are supplementary. So will just be cyclic quad. Cyclic quad. Or sometimes if you want to be very emphatic, you can say opposite angles of cyclic quad. All right, so opposite angles of cyclic quad would have taken care of that. So x becomes 180 minus 107. And if your math is in place, you should be having about 73 degrees as your final answer. Did we get that? Yes, we did. We did get that. All right, so that's taken care of. And we will be moving to another question. All right, give us a minute or two to calm ourselves down and we'll hit the road. So I can clean this one off while I get set for my next work. Now, I'm very deliberate about my drawings. So understand that I have decided to draw just to show you how it is done. Don't just work on looking at the questions alone. Try to draw. Because as you draw, certain aspect of your mind is being excited and it makes it easy for you to handle the problem. So let's look at this. Question 42 of that same year. It seems to be that for NECO, the pride is taking like 2 or 3 questions. Let's see. Let's solve. I don't know how this one is going to be because I'm very careful to avoid touching certain aspects so that I don't confuse you. But let's see. I hope. And as a matter of policy, I rarely solve questions before I come. I always do that just to check how I'm able to cope with the examination environment. And I think as a student preparing for work, you should do this more often. Take questions randomly and solve. Don't worry yourself about whether you're going to fail or pass the question. That's immaterial. You're practicing. Make a mistake, get yourself off the ground, dust off, and move on. Right, so with this, I'm going to have something like this. Right, so this will be my center if I got it right. And I think I'm having something like this. And this is O. All right, and we're having another one at this point. So I want to have T, I'm going to have S covered again. This arrow is always named in an order. So P, Q, R, S, T, right? Now, I'm told that this angle here is 109. It's 109 degrees. Now, I'm told to find angle. It said arrow T is a diameter. Arrow T is a diameter. What it means is that a diameter is a chord that passes through the center. A chord that passes through the center is a special type of chord, and we call that a diameter. Do you get it? I'm not confusing you. I'm just trying to play with words here. A chord is a special, rather, a diameter is a special type of chord that passes through that touches both ends of the circumference and passes through the center. Very important, right? And it's just one of a kind. Now, let's look at this. With that sorted, we can say that, now look at this, because this is diameter, this angle here, will be 90 degrees. That angle will be 90 degrees. I can close this up. Okay, now, what else can I do? Now, this is one where you really need to be very, one of those questions where you really need to be very careful with. But look at this. I'm trying to figure out if there's something in this question I am missing out. Is there anything given to me? 109. Okay, 109. Did I get this diagram correctly? Fine, okay, fine. I think I have a way out. Now, look at this. Look at the cyclic chord PQRS, cyclic chord. So using notations as in diagram. Using notations as in diagram, using notations as in diagram. Even some of us who are very skilled at this, sometimes the diagram can throw us off balance. Now, look at this carefully. Look at this part. Look at this part. Are you seeing that? I'm going to call that part X based on the cyclic chord. So I will say in cyclic chord, what? PQRS, comma. Now let me see, I'm told to find, but what I'm looking for will determine the direction. I'm told to find PRT, angle PRT. PRT. This is the angle I'm told to look for. PRT. This is the angle I'm told to look for. Have you seen it? That's the angle I'm told to look for. PRT. So I'm going to call that angle. Let me call that angle Y. That's the angle I'm told to look for. PRT. So I'm going to check the diagram. Which of those ones will help me? Now look at it very well. In cyclic chord, I said this will be X. Is that not? Cyclic chord X plus cyclic chord PQRS, Y, X plus 109 will be equal to 180 degrees. What's the reason? Cyclic chord. So the reason for that is what? Cyclic chord. So if that is in place, it will mean that X will be equal to what? 180 minus the 109. And that will mean that X will be equal to what? 71 degrees. Now, X is equal to 71 degrees. But remember that, let me call here Z now. Because I've said using notation as a diagram, any letter, I can begin to put letters to help my work. Now, Z plus X is equal to 90 degrees. What's the reason for that? Semicircle. How is it semicircle? Because we said that the semicircle, this is a diameter. And if this is a diameter, the angle it will form here must be what? The angle it forms touching the circumference must be what? 90 degrees, right? So with that said, I'm going to have that what? Z plus 71 will be equal to what? 90. And Z will be equal to 90 minus 71, which will give me 19 degrees. So that answer, that question will give me 19 degrees. I can clean this off. So that is 19 degrees. Now, look at this. I've gotten Z to be 19 degrees. So this angle here, please watch. This angle, watch this. Have the same segment. See what I've done? They have the same segment, what? PT. So we'll say that Y is equal to Z. What's the reason for that? Same segment. Same segment, PT. I'm being emphatic, putting the segment so that when you're revising, you know the segment you're considering. Same segment, PT. Look at the drawing. Watch me closely. Watch. So same segment means that this angle will be equal to this angle here. Is that clear? Right, so that solves that question. That means that Y will be equal to what? 19 degrees. But we're not told to look for Y. We are told to look for angle PRT, which is equal to Y and is equal to 19 degrees. So we have solved that. And we'll take it, we'll give ourselves a little time to catch our breath. Then we'll go to another year of questions. Okay, I think that's enough rest for us. Let's see how we can proceed. So I'll just do well to clean the board. Right, so we go to another year, and this year happened to be, which one is this? This should be NECO, I think. Yeah, this is NECO 2019. This is NECO 2019 OBJ. NECO 1920, NECO 2019 OBJ. And I'm going to try to draw the diagram. We'll start with question number 44. Question 44, let's see if there are questions before that. NECO has a very funny way of setting its questions. Just to be sure that I've not left any behind. So I will not be introducing Tilahaye. All right, so with that said, I'm going to do this. Right. And then I'm going to try to draw this. This is what my diagram looks like. This is 110. This is X. This is 50. And we are told to find the value of X. So to solve this, I will simply say using notations as in diagram. Using notations as in diagram. Using notations as a diagram, I'm going to have that. Now look at this. I'm going to call this Y. I'm calling that Y. So watch carefully. Y will be equal to 50 degrees. Y will be equal to 50 degrees. Why? Now look at it. Look at this. So let's imagine I'm bringing a segment here. This is one triangle on the same segment as this triangle. So Y will be equal to what? 50 degrees. So that will be what? Same segment. Now, look at this. The three angles here form a triangle. So I can say that X plus Y plus 110 degrees will be equal to 180 degrees. So that is angle sum of triangle. So I know Y is 50. So I'll have X plus 50 plus 110 equal to 180. Is that not? So X plus 160 will be equal to 180 degrees. Markers seem to be running out. And as such, I'm going to have that X will be equal to 180 minus 160 degrees, which means that X will be equal to 20 degrees. Okay, so the answer becomes what? 20 degrees. So X becomes 20 degrees in this question. Right, so we're taking care of 44. And then let's see if we can do 45. And in question 45. All right, so let's just give ourselves a minute or two to catch our breath. And then we'll proceed to question 45. Proceed to question number 45. Okay, so let's look at that now. We'll try to draw the diagram for 45, and it will look more like this. One of the reasons I write it here so that you can go back and look for the question paper. Right, this is what you have. Okay, markers are not. So this is what you're going to have, right? And then you're going to have something like this. Look at this. Okay. A center. Right. You are told that this angle here is 32. I am told that this angle here is 44. This is O, this is C, this is A, and this is what? B. Now you are told to find angle AOB. AOB. So to find angle AOB. How do you solve a question like this? Now remember that this is a radius. The distance from the center to the circumference is your radius. So this is equal to this. So what I do is to introduce another line. Such that all these are radius, or radii rather. Radii rather. So I have 1, 2, 3. Now look at this diagram. So I'm going to introduce letters now. I'm going to call this point X. I'm going to call this point Y. Now, if you look at this carefully, because of the unique arrangement of this triangle now, this is one isosceles triangle. So these two angles must be equal. This is another isosceles triangle. These two angles must be equal. So we have that what? A triangle A. Okay, using notation as in diagram, using notations as in diagram. Y will be equal to 44. Base angles of what? Isosceles triangle what? AOC. Also, X will be equal to what? 32. Base angles of what? Isosceles. Isosceles is short for isosceles. Isosceles triangle what? COB. Now, X plus Y from this description will now be equal to 32 plus 44, which will give me what? 76, if I've done my maths correctly. So with that said, angle AOB will be equal to 2 times angle what? Now remember that X plus Y is actually what? It's actually, so from here, to imply that what? Angle CACB is equal to what? X plus Y, which is equal to what? 76 degrees. Now that is understood. AOB will be 2 times what? Angle ACB. Is that clear? So what would that be? This will be 2 times what? What is ACB? What is ACB? ACB is 76. And as such, this will be 152 degrees if you have done your maths correctly. So that settles question 45 of that year. Right, so you see that the questions they set are technically very easy if you know what to do. So if you know the theorems to apply, it becomes very easy for you to handle them. Right, so let's catch our breath once again, then we'll return to work. So we've covered 3 years question, and maybe we'll try to do. There's a question here. It's an applied question. It's an applied question. I think funny enough, that year it was the only question the set there. It was the only question that was set there on arc, chord, and cyclic quadrilaterals. Let's confirm that. All right, we have about 8 minutes more to go, so we'll just try to handle this question and we'll call it a day. Just handle just this question and we'll do what, call it a day. All right, so I'll just try to draw the question and we'll trust that with this question, wrap it up, and then perhaps I think we'll continue with this tomorrow. I think I'm going to continue with this tomorrow so that I can clear out this series. All right. Now, we will be looking at this is WAEC 2019, if I'm right. This is WAEC 2019. So this is WAEC 2019. Maybe we should change the color of the marker. WAEC 2019, and we're looking at OBJ. Essentially, it is June. We want to really emphasize that. Most times, if I don't put June, it means it is June exam. That's question number 39. The very funny one. 70 degrees, center O, Z, Y, X. Now the question says, now this is 18 cm. The question says in the diagram O is the center, and the radius is what? 18. If the angle ZXY is what? 70 degrees, calculate the length of the arc ZY. So the length of the arc they want us to calculate is this arc here. Now, remember that it is the angle at the center that determines the arc. Now let's look at this. Length of arc will be equal to theta over 360 times 2 pi r. Is that not? We know r, but we don't know theta. Because theta here, theta equal to angle subtended at center. Theta is what? The angle subtended at what? Center. So if that is understood, it will mean that I need to look for this theta. So theta will be equal to 2 times 70. Angle at center equal to 2 times the angle at the circumference. Angle at center, angle at dot equal to 2 times angle at circum. So you see that if you don't remember this theorem, you'll not be able to find the length of arc of this figure. It looks simple, but little idea you don't remember can prove costly here. So which means theta equal to what? 140 degrees. All right. So once we get this, we can now find the length of the arc. So you see that this is one question where this theorem meets with what? Length of arc. So length of arc will now be equal to what? 140 over 360 times 2 times 22 over 7 times what? Radius, which is what? 18. So at this point I can cancel. I'll use this to cancel this first. 18 go here 1, 18 go here 2. This will go here 1, this will go here 2. 2 will cancel 2, so I'm left with what? 2 times 22, and that will be 44 centimeters. So if you've done that correctly, 44 centimeters will be your final answer. And I think with that, we can say truly we have done a good job tonight. I really want to thank as many of us that have stayed to the end of this class. The whole idea of this initiative is to have students do better in mathematics. And as God will give us strength, the plan is to have this every day, Monday to Friday. Sorry about yesterday, I had a very tight academic schedule and I couldn't keep up with the class. And the whole idea is to keep this class on every single day, Monday to Fridays. And let's see how much we can cover so that before your WAEC exam, you have enough resource materials to work on. My target is for students who are very strong, students who are average, and particularly for students who are weak. We have students who may find it very difficult to motivate themselves to sit and to write. You can play this as a movie. Watch as a movie, look out for Easter eggs, try to figure out where I made a mistake. And the more you figure out where I've made a mistake, the better you become at what you're doing. Thank you very much tonight. It is the Midnight Sun Experience. Mamu with Jarvis signing out. Thank you.